So we're on 1.6. We started that yesterday. We started talking about inverses, how if we get a table, we can just switch the x and y values, and that gives us the inverse. We talked about if we had a graph, it's supposed to be symmetric about the line y equal x. And on 111, they've given us a graph on page 72, if you want to turn there, so you can see the graph, a better copy of it. You do what you can, but it's never as good as the books. We haven't talked about taking a function and turning it into how we solve algebraically to turn one into its inverse function yet. So we'll do that, one of those today too, just to remind you the process there. Okay, so we're supposed to determine on 111, page 72, whether the two functions shown in the graph appear to be inverse functions of each other. We're supposed to explain our reasoning. Look really quickly at 112 before we do 111. Do you remember how we said that the functions were supposed to be symmetric about the line y equal x on 112 in your book? If you look at that picture, it's easy to see that one is. If you don't have your book open to page 72, please, because you can't see what I'm pointing at. 112 on page 72, it's easy to see that one is a reflection across that line y equal x. They've drawn the line y equal x onto the graph with red marking, so easy to tell. So does it look like it to y'all? Does it look symmetric about that line? No, I don't think it is, but there are sometimes when I look at these things, they fool me. What about, let's check it out. How could we figure out for sure if these two graphs are inverses of each other on 111, the green line and the blue line? What could we do? What would be one quick way to check, given what we talked about yesterday? If we find a point on one, what can we do to find the point on the graph of its inverse? Well, we just switch. If you remember, like if I have on the blue graph, it looks like we have the point 20, right? On the blue graph. So if the green graph is its inverse, it should have the point 02 on it. We just switch the x's and the y's to get an inverse, right? So does it look like the graph that I drew in green here, does it go through 02? Ooh, well, the green graph?
Oh, no.
That would be up here, wouldn't it? That red dot I made? That would be 02. So definitely not the inverse, is it? It didn't look like the inverse, and then we check a point out. No, it's not the inverse. So I'm going to put not the inverse. The other ones there, if you look at 112, 113, and 114, do all of those look like they're symmetric about the line y equal x on page 72? Could you kind of fold them over that line and they would match up? So 112, 113, and 114, we could fold it around that line y equal x. And inverses are symmetric about the line y equal x, so we know those are inverses of each other. I sure meant to have these on there. All right, so if you're going to find the inverses, anybody remember the process for finding the inverse if you want the equation of it? Does anybody remember how to do that from Algebra 2?
You switch the x and y.
So I'd want to write f of x as y, because I can't switch them if the y is not even down there, and I sure don't want to be moving that f of x all over the place, right? It's just a pain. So we're going to first write it in this, get it out of function notation, write the x's and y, and then we're going to do exactly what Hannah said. We're going to switch the x and the y. And you remember, you just pick them up, just the x and the y, and move them. You're not going to move 2x to the other side or anything like that. You're going to write just this sort of thing. You're just going to literally pick the x and the y up, and where you see the y, write the x, and vice versa, okay? And then you remember what you had to do last? Do we usually, what do you think? Go ahead.
Switch the sign?
No, we're just going to switch the two variables, and then we just solve for y. Yeah, because we wouldn't leave the function like that, would we? It would be kind of hard. You couldn't put it in your calculator to graph it for sure if you wanted to really look and see if you had done it correctly. So you just solve for y again. So if they don't give it to you with the x's and the y's in it, change that function notation there to y first, and then pick them up, switch them, and then we're going to solve for y. So you just have to do a little bit of algebra then. What would we do first to get y by itself? Add 3. And that'd give us 2y equal x plus 3. What would we do next? Divide by 2. That's all we got to do, and we'll have the inverse. Y equal x plus 3 over 2. You could also write that as y equal 1/2 x plus 3/2, right? Those are the same thing. So those would be the same functions. Why might it be easier for me? Why might I want to write it like this? It's in slope-intercept form. So if I had to go graph it by hand for some reason, or I could. Plus, it might be easier to put in the calculator that way. I don't know. It looks more familiar to our brains anyway. We kind of know what that means. So these two functions undo each other. And if you missed yesterday, or just to remind you for yesterday, when it tells you to verify that these are inverses of each other, you have to look at this as one function, and maybe we call this function the g of x. One way of notating an inverse is to say f inverse of x equal all that. But if we want to verify it, we have to show that f of g of x is x, and g of f of x is x. We have to show that they undo each other. If I take one function and plug it into the x on the other function, I should get x out, and vice versa. That's how we verify functions there. What could I do first here? Yeah, and I'd want to write the y instead of f of x first, right? Oh. Yeah, just making sure you remember to do that, because I know that if I don't point it out, if you had one on a test, you'd go, what? That doesn't look right. Okay, and then we just solve for y, right? We could add 3. We'd have x plus 3 equal negative 7/2 y. They solve for y, and then they call it g of x. It's a negative there. There's an equal sign, so it's kind of hard to read that. Let me put a red negative up here just so we remember it's negative. Okay, if I'm going to get y by itself, how do I get rid of that negative 7/2 in front of that y? Multiply by?
Negative 7/2.
Don't we have to do the reciprocal to get rid of it? Because we want it all cancel out and be 1y, right? So we could divide by negative 7/2, or we multiply by the reciprocal. Yeah, you're right when you say multiply. We just need to do the reciprocal, because our purpose in doing stuff is to get it to disappear off one side and get on the other. And if I multiply by negative 2 over 7, the 2's would cancel out, the 7's would cancel out, and a negative times a negative would be a positive y left on that side, wouldn't it? Okay, so I've got negative 2/7 times x would be negative 2/7 x, and negative 2/7 times 3 would be negative 6 over 7. So if we factor out the negative, let's try to make it match what's on the paper there. That's fine the way it is, right? There's nothing wrong with the way that's written, but here's what they have in the book, and it doesn't match our answer yet, but it really does. When they put this negative out front, they're meaning it for the whole thing. Do you see? Let me try to get rid of this one. Let me just kind of scribble it out. You see how they put it even with the fraction bar there? It's like it's out front of the whole thing. They're applying that negative to everything, every term on the top. If they multiplied it out, it's not like it's negative 2x plus 6. It's a negative of the whole fraction. So if we took a negative out of ours, it would be 2x plus 6. And aren't those like those fractions have common denominators? We could just put the 7 on the bottom. Then doesn't it look like theirs? Isn't that something tricky there with that negative in front of that fraction like that? Wouldn't it have been easy to think that's negative 2x plus 6? I mean, would you have thought to put the negative with both of the terms on the top if you were like multiplying that out? I might have messed it up, but do you see how that you have to be really careful about looking at the way they write something? If they'd wanted it to be negative 2x plus 6, they would have put that negative up with the 2x a little higher. So just be careful. That there's so many ways that with mathematical notation can get you. You look at it and it just looks a little weird, and